Welcome to the tutorial 1.6 part 1. So this is a new topic, dimensional analysis. And first, without being too long-winded about what that means, we're basically going to use this method to do a lot of the problem solving in this course all year. And the method is really just kind of like doing a unit conversion that you saw back in section 1.4 part 3. The difference is it's going to be like a whole string of these conversions. They're not always just going to be conversions, but they're always handled in the same way. So basically what we're going to do is solve a series of ratios, kind of one after the other, to address particular problems. And we're just trying to get used to the idea how to do it. Time conversions are really not relevant except for this. They're easy, and therefore we can get used to the method without kind of getting too bogged down with the complexities of it. So we're using time just to get used to the method. So let's try a couple of problems and just see how the method works. How would you calculate the number of minutes in 4.25 years? Now, I think most of you in your head would do something like this. You're going to say, well, I first have to figure out how many days I have in 4.25 years, so I'll multiply by 365 days in the year. Then once I know the number of days, like I'll do this calculation first, this ratio. Then I'll figure out how many hours it is by multiplying by 24 hours in a day. And now I have that answer, and finally the last thing is I'll multiply by how many minutes, 60 minutes in an hour. And that's exactly what we're doing here, but we're doing it kind of all in one big step instead of like piecemeal, one ratio, the second ratio, and the third. So place the numbers in here and see what you have. And if you look at this, this is exactly what you've done in your head is what we're going to do in dimensional analysis. Write down the number of years that you have, 4.25. First say, okay, I'm trying to get to a smaller unit that is down to the minute, so I have to go to a smaller unit. Well, I don't know how many minutes there are in a year, but I do know how many days there are in a year. So you multiply 4.25 times 365 and a quarter. Now you got the number of days. And then you keep going. Okay, multiply that number by how many hours are in a day, finally the minutes in an hour. And you notice these units cancel. Years cancel with years, days cancel with days, hours cancel with hour. So we know we set it up right. The only unit left standing at the end are the minutes. So therefore that has to be the right answer to the question, which is the number of minutes in this many years. A quick point about rounding. You might say, well, okay, this is your calculated result. Why did you round it to 3 figures? Don't you only have 2 figures here and here? But if you reflect on this for a moment, these are actually not measured values. Those are definitions. By definition, the 60 minutes in an hour, we didn't measure that. So these actually do not affect the rounding. This is not this is actually a measured value. This is not a definition. It takes a certain number of rotations of the Earth to get around the Sun, and that actually is something you'd have to measure. So therefore, this does have 5 figures. But we started with 3 figures at the beginning, so we round to 3. We're going to round, if the number that follows the thing we're trying to round to 3 in this case, we'll round up. So it's 2.4 times 10 to the 1, 2, 3, 4, 5, 6 to put the answer in scientific notation. All right, so that's the first one. Like I said, probably could just easily, of course, you could do this in your head, but you're trying to get used to this long string of dimensions being analyzed to solve problems in general. So let's try one that's less familiar. We're just going to reverse the calculation. If we had 4.25 seconds, if you're asked what fraction of a year is that, how would you do it? Well, basically you do the same thing, but you got to go work up to a larger unit starting from the 4.25 seconds. So in terms of the units, how would you do it? Say, I'm going to go from the seconds to the minutes, from minutes to hours, from hours to day, day to year. And finally, I know all this will be correct as long as I put the correct conversion factors in for each of these that's written here. So let's look at it. There is a minute for every 60 seconds. Don't make the mistake of saying there's 60 minutes in a second. That, of course, would be wrong. An hour has 60 minutes, etc. A day has 24 hours. So this 425 is going to be divided by 60, then divided again by 60, then divided again by 24, and divided again by 365 and a quarter. Don't keep hitting enter on your calculator as you do it. Just kind of keep saying divide, 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 because that's what you're doing to save yourself from making calculator errors. When you're all done, you'll get an answer, 1.3467 times 10 to the negative 7th. It'll say E minus 7 on your calculator. Then you just have to round it again. Here's the 5 significant figures, but 3 in the original number. are the measured values, so we have to round to 3. We round to 1.35 times 10 to the minus 7. So I hope this is kind of making sense to you. Let's try one where it's just slightly less familiar. The familiar time units is what we're using to gain confidence and familiarity, but a little bit less familiar, so familiar would be good, so we have still confidence if that's the case. How do we calculate the number of milliseconds in a day? Let's do it nice and slowly. Start off with what you're given. I have a day. I want to get to a smaller unit. I go to the hour. From the hour, I go to the minute. From the minute, I go to the second. Finally, from the seconds, I go to the millisecond. It's just this last ratio would be the one that's slightly less familiar. Just like the previous example, let's put in the numbers. There's 24 hours in a day, 60 minutes in an hour, etc. So I get to this stage here. I know the number of seconds, and I still have to multiply by the number of milliseconds per second. When I do, I get this large value, and I put in scientific notation with 3 significant figures, and I get 8.64 times 10 to the 7th milliseconds. You might be slightly puzzled. Why did I put 3 significant figures here? It was just a fudge. I'm going to go back to the slide so you see it. You were not actually told in the question how many significant figures we had. It says, how do we calculate the number of milliseconds in a day? It didn't give you a numerical value, so you didn't know. Was it 1 day, 1.0 day, 1.0? You didn't know. So I just assumed, as I always will in this class, if somehow the person or the text doesn't give you an actual value, just assume 3, just so we can all generate the same answer. Alrighty, that's it. Like I said, the number conversions will of course be very familiar, but remember, we're trying to build up confidence here to go on to the less familiar, which we'll get to by the time we're in 1.6 part 4, but we'll build up nice and slowly. All right, practice these first just to become really good at it, and then we'll go on from there. Great, thanks, we'll see you.